Okay, now what is database? A database is a organized collection of interrelated data. What is the definition of database is? A database is a organized collection of interrelated data. If anyone asks you what is database means, you have to give the answer. You have to give this answer. So it is a organized collection of interrelated data. Now, so, but what is this is? What is interrelated data? What is this organized? But usually everyone says collection of data. Database is what? Collection of data. But I'm saying, so it is a organized collection of interrelated data. What this means? For example, okay, like suppose you see this. You take, for example, this is a bank database. Okay, this is one bank database. A bank database stores data related to what? You take bank database. The bank database data related to what it stores? Data related to customers, data related to transactions, data related to loans taken by customers. So what is customer transactions loans? Customer transactions loans interrelated. Interrelated or not? Yes or no? So then next, you take one, for example, university. Every university maintains database. You take any university, every university maintains database. Let's say this is university database. A university database stores data related to students, courses, faculty, etc. Tell me, what is student, course, faculty? Interrelated. Customer transactions loans is interrelated. So a database stores interrelated data, but a bank database doesn't store data related to university students. A university database doesn't store data related to bank customers. Understood? Then, so a database stores what? Interrelated data. And also, what is this is? This is what? Organized. What is organized means? So in database, not only storing the data is important, the data must be organized. If the data is not properly organized, accessing is difficult. In database, not only storing the data is important, the data must be organized. If the data is not properly organized, accessing is difficult. Example, you take libraries. In libraries, they keep the books in racks. Suppose assume all books are kept in one rack. If all the books are kept in one rack, what the problem is? All books, computer science, electronics, electrical, mechanical, civil, all books are kept in one rack. If all the books are in one rack, problem is what? Problem is accessing particular book. Finding the particular book is time taking or not? Yes. Suppose if they keep separate racks, one rack for computer science, one rack for electronics, one rack for electrical, then finding the book is what? Easy. Okay. So, however, books are organized in library. Same way, data is organized in database. If the data is not well organized, accessing is difficult. So, but here, how they organize the data in what? Databases. So in database, data organized in the form of tables. So what is the structure we use? What structure we use? Tables. We use a table for organizing the data in database. Like suppose, for example, in database, You want to store customer data. Create one customer table. In customer table, store the customer's data. You want to store loans data. Then create one loans table. In loans table, store the loans data. So then in libraries, they use racks for organizing the books. But in database, we use what? Tables for organizing the data. So suppose you want to find the customer data. To find the customer data, go to customer table, find the customer data. You want to find out the loans, then go to loans table, find out the loans data. Understood? So that is the reason in definition, what I said, organized collection of interrelated data. Next, for example, a university database stores data related to students, courses, faculty, etc. So this is what database. So if you like attend interviews as a fresher, experienced means they don't ask. They don't ask what is database. Okay, na? Experience. But if you have fresher level, then compulsory they start with what? Basics. Okay, na? Then because I have seen so many students, but they complete course, Oracle course, SQL Server, they complete the course, but they can't properly like what give the definition if they ask what is databases. Okay, na? Then so basic terminology is important. Okay, then but in some years back, if you take 10 years back, 15 years back, companies used only one database. But nowadays, every company uses two databases. Nowadays, companies using what? Two databases. What are the types of databases? Okay, then. But some years back, companies used only one. But nowadays, every company uses two databases. What are the types of databases? Databases are two types. One is anyone knows? One is what? OLTP. Another one, OLAP. So databases are two types, OLTP, OLAP. Then what is OLTP stands for? OLTP database, OLAP database. What is OLTP stands for? OLTP stands for online transaction processing. Online transaction processing. Then what is OLAP stands for? Online analytical processing. So nowadays companies are using two, OLTP and OLAP. Then but question is why they are using two databases? What is the need? Like why we use database? Storing data. So purpose is storing the data. For storing the data, why they use OLTP, OLAP? Okay, na? Then see any whether it is OLTP or OLAP, but purpose is storing the data. But this is used for one purpose. This is used for a different purpose. Purpose is different. Usage is different. This is used for one purpose. This is used for another purpose. The first one, this is used for storing day-to-day transactions. The first one is used for storing day-to-day transactions. Like example, what is day-to-day transactions means? You take bank. In bank, what are the day-to-day transactions in bank? Customers go to bank or customers go to ATM. They do money withdrawal, money deposit, money transfer. When you do money withdrawal, then immediately where the details are recorded, every transaction is recorded or not? Yes, but where the transactions are recorded in one database, what the database is? OLTP. OLTP. So every transaction is recorded in one database, that is OLTP. Okay, then. So now, sometimes when you go to bank, like bank people says, boss, server is down, wait for 10 minutes, wait for half an hour, like that. Yes or no? That means which server is down? Bank OLTP server is down. When OLTP server is down, that will not allow the transactions. That's why bank also, it will not allow the transactions. Got it? So then first one is every transaction is recorded in OLTP. So this is for storing the day-to-day transactions. And what for the second one? Okay, what for the second one? And the second one is used for analysis. The second one is used for analysis. If bank wants to analyze the data, they use OLAP. So the first one is for storing day-to-day transactions and second one is for analysis. So bank wants to analyze the data. Okay, they want to analyze the last 5 years customer loans data. Who is paying, like whose payment is what, time to time, who is not paying well. Okay, now they want to analyze the last 5 years loans data. So then which database they use? OLAP. So one is for storing day-to-day transactions, one is for analysis. One is for running the business, another is to analyze the business. The first one is for running the business and the second one is for analyze the business. Because some years back, companies' focus is only running the business. Those companies' focus is only running the business, but nowadays companies' focus is running plus analyzing the business because there is a huge competition in every industry. So that is the reason companies spending money on what's it? Data analysis. Companies spending money on data analysis. So that is the reason the new technologies came into the market. What is that is? Hadoop. Hadoop came into the market. Next, there is a call Spark and what's that? Scala came into the market. Next one, data science came into the market. Why this came into the market? So industry introduced number of frameworks, Hadoop, Spark, Scala, data science, all this came into the market. What are these? They are mainly the frameworks, mainly they are used for data analysis. They are mainly used for what? Data analysis. Sir, okay, na? Understood. Then, so that means these technologies comes under which category? OLAP, Hadoop, Spark, data science, they all comes under which category means OLAP. You take, for example, Java, .NET, PHP, like this, Python. Then tell me, so all this comes under which category? By using Java, .NET, PHP, what type of applications you develop? You develop what's it? OLTP applications by using Java, .NET, etc. By using Hadoop, Spark, Scala, data science, which type of applications you develop? OLAP, data analytics applications you develop. Sir, okay, na? Understood that. Now, so tell me, SQL Server is what? SQL Server. Okay, SQL Server. SQL Server is used for which purpose? SQL Server used for which purpose? Okay, na? SQL Server. You use SQL Server to maintain the database. Yesterday we said, but SQL Server is used to maintain which database? OLTP na, OLAP na? OLTP na, OLAP na? So SQL Server can be used to maintain both OLTP, OLAP. SQL Server can be used for OLTP. SQL Server can be used for OLAP. So we can use it for day-to-day transactions. We can use it for data analysis. Then you'll get a doubt. Sir, when we can use SQL Server for data analysis, why Hadoop came into the market? Why Spark data science came into the market? Yes or no? You can use SQL Server for analysis. When we can use SQL Server for analysis, why these technologies came into the market? So reason is simple. SQL Server is the best tool for analyzing structured data. Hadoop data science, they are good for analyzing what? Unstructured data. SQL is the best tool for analyzing structured data, and data science, like what? Data science, next one, Hadoop, Spark, they are good for analyzing unstructured data. You know, structured and unstructured means the data is in tabular form. Data is in table form. What is that is? Structured. So the data is in like PDFs, images. Then what is that is? Unstructured data. Okay. Then, so like for example, traffic, you take traffic department. They capture the images from this junctions. They capture what's it? Images. They capture the images. They got 1,000 images. What that images contains? Face. The person face is there in that image. So they want to find out who is wearing mask, who is not wearing mask. They want to find out. That we cannot do with SQL Server. SQL Server is not for that. We don't use SQL Server for that type of analysis. Then which tools are used? So I want to read the images. I want to find out which face is having mask, which is not having mask. Then which one we can use? Hadoop, data science, Python. We can use that one. Understood or not? Okay, na? Then. So that is the what? This one. Like now. So like OLTP organizations uses OLTP database for storing day-to-day transactions and OLAP for analysis. Okay, then. And OLTP for running business and OLAP is for to analyze business. OLTP is for running the business and OLAP is for to analyze the business. Okay, then. So if I ask who is the best player in the cricket, have you answered that? I'll ask who is the best player in the cricket. Can you decide that from current match? Suppose yesterday one match was there. Based on that match, can you decide who is the best player in Indian cricket? No. Okay, na? That you cannot decide from only one match. If you know past 10, 20 matches or past 1-2 years matches, then you can decide who is the best player. Yes or no? So we has got consistent consistent record, consistent playing. Then you can decide based on that. Okay. So that means here for deciding who is the best player, what you need, what data you require, previous, that means what is that is called history. What that is called? History. So what you need is, you need history. You need historical data. If you need historical data, then we can decide, we can analyze. So OLTP stores only current data. OLAP stores historical data. So listen, what? This OLTP stores only current data, present data. But OLAP stores what? Historical data, last 5 years, last 10 years data stored in OLAP. So that's why we can use this for, it is storing historical data. When it is storing historical data, then we can use this for analysis, but we cannot use this for analysis because it stores only current, present data. Based on the present data, you cannot do the analysis. For analysis, what is required is history is required. So this database stores what? Historical data. Understood now? Why can't we use OLTP for analysis? Okay. Then now, what are the like day-to-day operations? What are the day-to-day operations on database? Already you know. What are the day-to-day operations on database? Okay, the day-to-day operations are any database you take, whether it is a bank or university, any database you take, what are the day-to-day operations? Mainly 4. Yesterday also I given. What are that 4? CRUD. What that stands for? Create, read, update, delete. So create the data, read the data, update the data, delete the data. So the day-to-day operations on database includes 4. Then, okay. So for example, a customer opens account in bank. When customer opens account in bank, his details are what? Created. We create the data. Next, customer want to check the balance. That is called reading. Customer deposits some amount, updated. Customer wants to close the account, then delete. So any database you take, the day-to-day operations are 4 CRUD operations. CRUD, create, read, update, delete. Next, can we directly perform these operations on database? Then, so can we directly perform these operations on database? Like user CRUD. Can we directly do these operations on database? Huh? This is possible or not possible? Not possible. You can't directly work with what's that? Database. You need a software. You need a software. What that software is called? That software is called what? DBMS. Okay. Now, so what is database? What is DBMS? Database is a storage. Database is a storage that stores data. What is DBMS? Is a DBMS is a software that manages what? Database. So one cannot directly work with databases. One can work with databases through DBMS. Then, so what is DBMS stands for? Database Management System. Okay. Then, so which is a software used to create and to manage database. So if anyone wants to, in your laptop, you want to create the database, you want to work with the database. To create the database, to work with the database in your laptop, first of all, you have to install what? DBMS software. After installing DBMS software, then you can work with database. Okay. Then, now you want to develop website. develop website in your laptop, first you have to install some softwares or not? Yes. Similarly, to create the database also, first you need to install some softwares. What that softwares are called? DBMS softwares. Okay, then. So now, like you can say, a DBMS is what? DBMS is an interface. It is an interface between user and what? Database. So you can say like it is an interface between user and database. So how user works with database? User work with the database through a DBMS software. So like if you want to, okay, then like user uses what? DBMS works with database. So user wants to update the data. User gives request to what? DBMS, and DBMS will go to database and update the data. And user wants to delete. User gives request to DBMS, and DBMS will go to the database and delete the data. So if you want to do any operations, you give request to DBMS, and DBMS will go to database and perform the operation. Okay, then. So we can say it is what, sir? Interface between user and database. Next, what is the evolution of DBMS? Okay, what is the evolution of DBMS? Evolution means evolution. Evolution means you don't know. Huh? Evolution means what is the English meaning of evolution? Huh? Okay. So then evolution means, like for example, evolution of telecommunication. Evolution of telecommunication. So just go to this images. Then, so this is evolution of telecommunications. What is the, in the olden days, which phone is used for communication? Which phone is used? Later, which phone is used? Next one, which phone is used? Next, which one? Next, smartphone. Okay, na? What this is called? Evolution of what, sir? Telecommunication. Evolution means step-by-step development. What is the English meaning of evolution? Evolution means what? Step-by-step development. What is the step-by-step development of DBMS? In the very beginning, which systems were used for storing the data? In the very beginning, when computers introduced into the business, which systems were used for storing the data? That means in 1960s. In 1960s, companies were used FMS. 1970s, companies were used HDBMS. Next, they were used NDBMS. 1980s, companies were used RDBMS. 1990s, companies used RDBMS. Okay, then. So 60s, companies used FMS. 70s, HDBMS, NDBMS. 80s, RDBMS. 90s, RDBMS. So this is the step-by-step development of what's that? DBMS, data storage. So what is FMS stands for? FMS stands for File Management System. FMS stands for File Management System. What is HDBMS stands for? HDBMS stands for what? Hierarchical DBMS. What is NDBMS stands for? NDBMS stands for Network DBMS. What is RDBMS stands for? RDBMS stands for Relational DBMS. What DBMS stands for? What is that is? Object Relational DBMS. So this is step-by-step development of DBMS. Okay, now then next. But here actually, sir, do we need to know about this? Okay, now do we need to know? Do we need to learn this? Okay, now then actually see what you need is, see, these systems are outdated. These three are what's that? Outdated. No one using it. No one using FMS. No one using HDBMS. No one using what's that? NDBMS. Nowadays, maximum land phones are what? Maximum. No one using what? Land phones. Everyone using what? Mobile phones. Yes. Now, similarly, these systems are outdated. No company using FMS. No company using NDBMS. Nowadays, companies are using only two. What are the two? Companies are using RDBMS and RDBMS. Then what you need to know, you need to know about this. You need to know about RDBMS and RDBMS. You don't need to learn what's it, HDBMS, NDBMS. Nobody will ask. Okay, then they're outdated some years back. Not now. Some years back they're outdated. Okay, then. So what we start with what? We start with RDBMS. So now if anyone asks you like types of databases means, if anyone asks you types of databases, then just now we discussed. You have to say what's the two? What are the two? OLTP, OLAP. I'll ask types of DBMS. What are the types of DBMS? Then if I ask types of DBMS means the different types. What are the types? One is just now I given no? HDBMS. Next NDBMS. Next RDBMS. Next RDBMS. So what are these different types of DBMS? So database management system types. Okay, then. But sir, remember one, whether it is HDBMS or NDBMS or RDBMS or secondary. Primary is what? Like what is database? What is DBMS? Database is storage. DBMS is a software to manage the database. So the DBMS are classified into 4 types. Then, so but what I'm saying is the systems are outdated. No need to discuss. Then what we need, you need relational and object relational. So we'll start with what? We'll start with RDBMS. Okay, we'll start with RDBMS. Then RDBMS concepts. RDBMS concepts introduced by EF card. Sir, after discussing, you'll understand like what is SQL Server is. After completing this, you'll understand what is SQL Server. You can able to answer if anyone asks you what is this SQL Server means, you can give the exact answer if you know all this. So RDBMS concepts introduced by EF card is the one who introduced RDBMS concept. Okay, then. Understood. Then, so this is the person who introduced what, sir? RDBMS concept. Then, so like, okay, then So he's the one who introduced what's it? RDBMS concepts. Then now, and what he introduced is like EF card introduced EF card. EF card introduced 12 rules. Is introduced 12 rules. They're called card rules. The CF card introduced 12 rules. They're called card rules. Card rules. Then, so like oops, you take oops. Oops comes with some futures. What is that is? Oops. Oops comes with some futures. What is that futures? Abstraction, encapsulation, inheritance, polymorphism. So they're all what's that? Object-oriented programming concepts. RDBMS also comes with some features. How many features? 12 features. Any language that supports all the features of OOPS is called perfect object-oriented programming language. Yes or no? Similarly, a database that supports all the features, all the rules, 12 rules, then it is called perfect RDBMS. A software that supports all 12 rules is called perfect RDBMS. Okay, na? Then so now, like suppose here, then a software, okay, na? A database software that supports all 12 rules is called perfect RDBMS software. Then supports, then it is called perfect RDBMS software. Okay, then so like what is that is? One rule is according to EF card, in RDBMS, data must be organized in what's it? What? Tables. Okay, according to EF card, in RDBMS, data must be organized in tables. That is rows and columns. So that means inside the database, how you organize the data? Inside the database, how you organize the data? That is what, boss? How the data organized? In the form of tables. In the form of tables. Okay, then no. So like suppose here, let's say for example, then let's see, suppose for example, this is the database. Okay, this is the database. So what is this is? I'm using what's that? RDBMS. So this is RDBMS software. Then what is this is? Database. So inside the database, how you organize the data? You organize the data in the form of what? Tables. The tables means rows and columns like this. Okay, then so this is how you organize the data in databases. Okay, so if the software is what? If the software is what, sir? RDBMS. Suppose for example, it's not RDBMS, like it is what? For example, not RDBMS, like for example, you are using what's it? You are using HDBMS. Like once again, this is database and you are using which one? You are not using RDBMS, you are using what? HDBMS. So inside the database, how the data organized? Data organized something like this. What is that is? What is that is called? That is called what's it? What is this is? Hierarchy. What is this is called? Hierarchy. So if you use HDBMS, data organized in tree structure. Data organized in tree structure. If you use RDBMS, data organized in tables. That means one DBMS to another DBMS. What is the difference? Okay, na? One DBMS to another DBMS. What is the difference? The difference is the structure. Structure is different. In HDBMS, we use one structure. In RDBMS, we use different structure. Ah. Ah. Hmm. So, okay, na? Then one DBMS to another DBMS. What are the difference is one structure. So in HDBMS, we use hierarchy, tree structure. In RDBMS, we use table structure. But here, see, these structures are failed. We should not say failed, but they are complex. They are what, sir? Complex. But when it comes to RDBMS table, when this structure is introduced, then operations became simple. Operations became what, sir? Simple. Operations means what? Crude operations. What are the crude? Creating the data, reading the data, updating the data, deleting the data is what became simple. But earlier, that operations are what? Complex. Now, after introducing this table structure, operations became simple. When structure is simple, so most of the companies started using what, sir? Databases. Okay, na? Earlier, companies were using file management system. Once RDBMS is introduced, most of the companies started using what? Databases. So then RDBMS became what, sir? Popular. And once it is became popular, most of the companies introduced their own RDBMS. Okay, then. So what I said, like here, data organized in tables. That means rows and what, sir? Columns. Like suppose, for example, I want to store customer data. Then how the customer data stored? Customer data stored like this. Customers, then, so the data stored like this. In the form of tables means rows and columns like this. So inside the database, how customer data stored? Inside the database, how customer data is stored? Then customer what's that? ID, customer ID, customer what's that? Name, customer address, customer ID, name, address. Then what is this is? ID, name, address. Next one, what is this is? 10. Suppose name, some name, Sachin, some address, HYD, like 11, some name, for example, some name, some address. Okay, then, for example, some name, okay, some address, something, BLR. Okay, then, so the data in RDBMS, data stored like this. How customer data stored? Customer data stored like this, rows and columns. So what are these verticals are called? What are these verticals? What are these verticals are called? These verticals are called columns. Then, so these verticals, all these verticals are called columns, or you can say columns, or you can say fields, or you can say attributes. What are the different names used? You can call it as column, or you can call it as field, or you can call it as attributes. In this table, how many fields are there? In this table, how many fields are there? 3 fields. One field is customer ID, one field is name, one field is address. Then next, what is this horizontals are called? This horizontal is called, this horizontal is called row. Then record, next tuple. So the verticals are called columns, or fields, or attributes, and this horizontal is called row, records, tuples, TUPLE, tuples. Okay, so in this table, how many records are there? In this table, how many records are there? 3 records. The first one is not record. What is the first one contains? First one contains field names. So this is not record. So this is record. This is record. This is record. How many records are there? 3 records. Record means that contains the data. So this contains the data. This is the record. This contains the customer data. This contains customer data. This is the record, but this doesn't contain the customer data. This is not record. Sir, got it? Okay, then. So now, what is this like 10? What is this 10 Sachin HYD? What is this 10 Sachin HYD? Data, values. They're called values. So 10 is a value for customer ID. What is Sachin? Value for name. What is Delhi? Value for address. Okay. So what is row contains? Row contains values, field values. Value for ID, value for name, value for address. A row contains field values. Okay. Then, so this is the table. Like, so this is simple structure. Okay. Then, now see, according to what EF card said, then database is equal to what is said? Database is collection of what's it? Tables. What is said? Database is collection of tables. Database contains tables, and every table contains what? Collection of rows and columns. So database contains tables. A table contains rows and columns. What is row contains? Row contains what's it? Collection of field values. Okay. What is column contains? What is column? You take address column. Address column contains what? Values. Values assigned to address field. And this name column, second column contains values assigned to name field. That means collection of values assigned to one field. What is column contains? Collection of values assigned to one field. Okay. Then, so what is column is collection of values. Collection of values assigned to one field. So database contains tables. Table contains collection of rows and columns. Row contains collection of field values. A column contains collection of values assigned to one particular field. So this is the definition of what's a database according to EF card. Okay, then. So that means in RDBMS, you want to store something in RDBMS. First, what we have to do? If you want to store something in RDBMS, first what you have to store? What you have to first create one table. You want to store employees data. Then first create one employee table, store the data. You want to store customers data. First create one customer table. In customer table, store the customers data. So something you want to store in database, first create one table. Okay. Then next. And what EF card said, every table must contain, every table must contain primary key. Okay. Every table must contain primary key to uniquely identify the records. Okay. Then according to EF card, every table must contain primary key to uniquely identify the records. Then so what is the meaning here? What is the meaning primary key? Okay, then just listen this. You'll understand what is this. See, for example, every bank stores customers' data. Yes or no? They store like this: customer name, customer address, customer balance. They're storing like this: customer name, address, balance. Then, so, but if they store like this, what is the problem? Bank is storing customer data like this, name, address, balance. But if they store like this, what is the problem for bank is? No problem. Any problem is there? Yes. What? If they store like this, what is the problem for bank is, like uniquely identifying customers is difficult. Uniquely identifying the customers is difficult. What is the meaning? Suppose I'll go to the bank. I'll ask, sir, what is my balance? What is my balance? Then they'll ask, what is your name? My name is Vijay. Then they go to customer table, find out the customer with name Vijay. But what they can find number of customers with name Vijay or not? Yes. They can find number of customers with same name. Yes or no? Then they'll ask my address. They'll ask my address. I'll give my address. Again, they can find number of customer with same address also. So what is the problem is? Problem is uniquely identifying customers is difficult. Yes, that is the reason every bank introduced one. What is that is called? Account number. Every bank introduced one. What is that is called? Account number. What for account number? To uniquely identify the customers. One account number is given to one customer. The same account number is not given to another customer. So using this account number, they can uniquely identify the customers. Yes. So now I'll go to bank. I'll ask, sir, what is my balance? Then they'll ask, what is your account number? I give my account number. But how many customers they'll find with one account number? Only one customer. So this is uniquely identifying. What is this is called? This is called primary key. What this is called? Primary key. What is the purpose? Uniquely identifying. Suppose like every company stores employees data. So they're storing like this. What is that is? E-name, job, salary. They're storing like this. Name, job, salary. But what the problem is? So there may be number of employees with same names, number of employees with same jobs, number of employees with same salaries. Then what the problem is? The problem is uniquely identifying the employees is what? Difficult. So that is the reason every company introduced one. What is that is called? Employee ID for uniquely identifying. What is this is called? This is called what? Primary key. So what are the examples for primary keys? Okay, na? What are the example for primary keys? Like what? Bank, what's it? Account number. Next one, employee ID. Okay, na? Employee ID. Student roll number. Yes. Like how Indian government uniquely identifies the persons by using what? Aadhaar number. So earlier there is no mechanism to uniquely identify the persons. Then that became difficult for government. So that is the reason what they introduced. They introduced what's that? Aadhaar number. How income tax department uniquely identifies the taxpayers? PAN number. How election department uniquely identifies? Voter ID. So there are all examples for primary keys. The main purpose is to uniquely identify. Okay, then no. So like that's all. The main purpose is to uniquely identify. Okay, then. So, but what is RDBMS is? RDBMS is a theoretical concept. Relational data model is what, sir? Relational database is what? Theoretical concept. Who is that introduced that theoretical concept? That is introduced by this person. Okay, na? He like design RDBMS means so inside the database, data must be organized in tables. Next, every table should contain primary key, rows and columns. Like he introduced this concept. Okay, na? Then what are the softwares implemented the features of RDBMS? Like once again, sir, what is OOPS? What is Java? What is OOPS? What is Java? You know, no? Java. Java means, now I'm not asking what Java language. Then Like, like what is OOPS? What is Java? OOPS is concept. OOPS is what? Theoretical concept. What is the Java is? Java is the language implemented the features of OOPS. One is theoretical concept bus. Another one is what? A software, a programming language implemented the features of OOPS. Okay, like Java. Next one, what's it? What is that is? C#.NET. Next one, what's it? C++. What are these? Tell me. All these languages, programming languages implemented the features of OOPS. Okay. Then similarly, RDBMS is what? A theoretical concept that is introduced by EF card. What are the softwares? RDBMS softwares. What are the softwares implemented the features of RDBMS? Okay, na? What are the softwares implemented the features of RDBMS? Okay, na? Then one is what? One is SQL Server. One is Oracle. One is DB2. One is MySQL. One is PostgreSQL. Like, what are these? All these are what's that? All these are RDBMS softwares. Like, for example, top 10 RDBMS softwares. So then you can go through this list. Okay, na? Then the best relational, what's it? The database management systems. Okay, the best relational database management system. What this is? First one. What is the first one? Okay, na? First one. What this is? Microsoft SQL Server. What is the second one? Oracle database. Another one, Amazon RDS, Amazon Relational Database. So this is Amazon RDS. Next one, what's it? MySQL. Then IBM DB2. Then SAP HANA Cloud. Okay, na? What is this is? PostgreSQL. Amazon Aurora, Azure SQL Database. This is also Microsoft Single Store. Okay, na? MariaDB. Okay, all these are what's it? RDBMS softwares. Okay, then RDS, Amazon, like. So they're from different companies. They're from what? Different companies. Okay, and all are belongs to same family. What that family is? RDBMS family, but they are from different companies. Like you take SQL Server. SQL Server is from Microsoft. Oracle is from Oracle Corp. DB2 is from IBM. MySQL is from, this is also Oracle Corp. PostgreSQL is from, okay, na? PostgreSQL. So PostgreSQL is what? They're from like this one. So okay, then so PostgreSQL Forum Development. Okay, then RDS. RDS is from what? Amazon. So they're from the different RDBMS softwares. Now tell me, what is RDBMS? What is SQL Server? RDBMS is theoretical concept. RDBMS is theoretical concept. What is the theory? Inside the database, organize the data in the form of tables, rows and columns. Every table should contain primary key, like that. So theory. Then, like, what is SQL Server? SQL Server is a software implemented the features of RDBMS. OOPS Java. Like OOPS is theory, Java is a language. Like RDBMS is theoretical concept and SQL Server is what, sir? A software implemented the futures of RDBMS, practical implementation of RDBMS. Okay, then. So now, so these are all what's that? Like they're all belongs to one family. Okay, then understood. So like which one is used depends. Sir, client is using Microsoft products. If client using Microsoft product, then they prefer SQL Server. So client is a Oracle client, is using Oracle products. Then he uses Oracle database. IBM clients, they use DB2. Amazon clients, they use RDS. Okay, na? Then that's all. So, so these are all like the different database softwares. Now, so if anyone asks you like what is SQL Server, then what is your answer now? Huh? What is SQL Server? What is SQL Server? SQL Server is a RDBMS product from what? Microsoft. So it is a RDBMS product from Microsoft, used to create and to what's it? Manage database. What for SQL Server is used? SQL Server is used for creating the database and managing the database. Okay, na? Then. And all these are used for same purpose or different purpose. All these are used for same purpose or different purpose. Oracle, SQL Server, they are used for same purpose, but they are from different companies. Java, C#, they are used for same purpose, developing web applications. Sorry, programming language. In web applications, you need a programming language. You can use Java or C#. Their purpose is same, programming, object-oriented programming. Here also what's the purpose is same. What is the purpose? To maintain the database. So there is a HDFC bank is there. They want to maintain the database. To maintain the database, they use either of this. They use either SQL Server or they use what's that? Oracle. So they can use any of this one. So if any company wants to maintain the database, they use this. Okay, then. So now, what the next one is? Like, what the next one is? ORDBMS. ORDBMS. What this stands for? What it stands for? Object Relational DBMS. Then, now we can say it is the combination of what? RDBMS and OOPS. Okay, na? It is a combination of RDBMS and OOPS. Means ORDBMS is equal to RDBMS plus OOPS. RDBMS plus OOPS. So the previous one is RDBMS, but this is combination of RDBMS and OOPS. It is a mixture of two, RDBMS and OOPS. That means here also how data organized here. Here also how data organized in the form of tables only. Why? Okay, na? Here also data organized in the form of tables. Why? Because basically it is one RDBMS. Basically this is also RDBMS. So here also data organized in the form of tables. Then apart from this, one concept is added, OOPS concept. What is the main concept of OOPS? What is the main concept of OOPS? Means you know what that is. What is that is? Data what's that? abstraction, data what? Encapsulation. Okay, na? Encapsulation. Next one, inheritance. Next one, polymorphism. Okay, polymorphism. So these are all the main concept of what? Oops. But all these concepts mainly for two reasons. They introduced this concept mainly for two. What are the two? One is what, sir? Security. Another one, what, sir? Reusability. Actually, the OOPS main concept is two. Security and reusability is the main concept of OOPS. Okay, na? So you take four. Anything you take in this, either this is related to security or it is related to reusability. Okay, na? But here we don't need security. Okay, na? Databases, we don't need security because it offers what, sir? Security features. Security is not taken from OOPS. What is taken from OOPS is reusability is taken. Sir, RDBMS provides security. So we don't need security from OOPS. What is taken from OOPS is reusability is taken. Okay, then so the reusability is taken. Like what are the difference is RDBMS what? RDBMS what's it? RDBMS doesn't support reusability, but what DBMS supports? Reusability. This is the main difference. It's not completely different. So just some extra features are added, and the extra features are related to OOPS. Okay, na? Reusability. Okay, then. But how reusability is introduced, we'll see that. How reusability is introduced. Okay, na? We'll see that after going to this. Just only the difference is this is the difference. Okay, then. So what software support this? What software support this? What DBMS? What software supports? See this. So what is saying? Like this is PostgreSQL. Is a powerful open source object relational database system. That means PostgreSQL supports what DBMS or not? Yes. Like that, there are number of. One is what, sir? One is what? Oracle supports. Another one, SQL Server supports. Another one, just now I shown. What is that is? PostgreSQL supports object relational. There are number of support this. Okay, then. Now, if I ask you, now what is SQL Server means? Now, what is your answer? What is SQL Server means? What is your answer? SQL Server is basically a RDBMS and also support the features of RDBMS. Basically, RDBMS and support the features of RDBMS used to create and to manage database. I'll give that. Okay, na? Then. So this is what the examples for RDBMS. It is not completely different, just extension. That is OOPS, but that is reusability. But how it is introduced, how reusability concept is introduced, we'll see that after going to the actual codes. Okay, na? Then. So that's all. We'll continue this tomorrow. Okay, na? Then. Okay. Oh, yes. Like we'll see. We'll see. Yes. Because this is not the 1.5 to 2, 1.5 to 45 days. 2 around over 10 days extra. Material ఇక్కడ ఉంటుంది ఓకేనా జిరాక్స్ Vijaykumar sir. జావా అయితే ఒరాకిల్కి జావా నేర్చుకోవాలంటే ఒరాకిల్కి .NETకి వెళ్ళాలి అంటే SQL సర్వర్కి రా ఫస్ట్ అది డిసైడ్ చేసుకో దెన్ నెక్స్ట్ బ్యాక్ ఎండ్ ఓకేనా దీని మీద బేస్ అయ్యి బ్యాక్ ఎండ్ ఫ్రంట్ ఎండ్ ఉండదు ఫ్రంట్ ఎండ్ మీద బేస్ చేసుకొని బ్యాక్ ఎండ్ ఉంటుంది you want to learn Java then go to Oracle you want to learn .NET then come to SQL Server yes నీ ఇష్టం అది నువ్వు చెక్ చేసుకో ఒకసారి ఓకేనా కొన్ని రోజులు ఇక్కడ అటెండ్ గా తర్వాత 1 or 2 days అటెండ్ గా ఆన్లైన్ ఇట్ ఈస్ ఓకే దెన్ కంటిన్యూ నాట్ ఓకే దెన్ కమ్ టు ఆఫ్ ఎస్ see here online students see for videos etc okay na you have to wait for 2-3 days after 3 days registrations will be completed and so they give the details everything they give the details admin details everything they give the provide the details okay na then you have to wait everything will be provided boss fees duration material videos everything you have to wait okay na then just wait for 1 or 2 days they give the details then they give the admin details they give everything that's all boss you're all like asking not related to this class installation everything will be covered you have to wait we are going step by step Everything will be covered. Unnecessarily, you are like, why confusion comes? Because when you think too much, that's why confusion comes. Like just first 2 3 days, like you attend. That's all. You attend the demo classes. Everything you'll get. How to register? What is the fee? Everything will be given. So for Python, we can anything is okay. What they what you need is you need database knowledge, how to write queries. So that you can learn either using SQL or using Oracle. Anything is okay. So, but better to learn SQL Server. Okay, now? So class, I given, you are not seeing my window. I given class starts at 11:30. Tomorrow also class starts at 11:30. 11:30 to 12:45. 11:30, not 11 to 12:45. Sorry, 11:30 to 12:45. Okay, 12:45. Last 5-10 minutes I'll use. Last 10 minutes for your doubts clarification. And 11:30 to 12:45. Okay then. Okay then. So, bye. See you. Like see you tomorrow. So see you tomorrow at 11:30. Okay. Bye. Okay, guys, I see you tomorrow.